Good morning, dear students. Previously, we discussed, I completed 15 parts. This is the 16th part. It may be the last one for this chapter matrix. And we are in exercise 3.4. It is an important concept, already I told you. That is finding of inverse of a given matrix. I solved some problems. Now I am going to solve the 6 and 7, 8 are given as homework and 9 is there. Okay, now already I wrote the solution on the board. Okay, now right. Slowly observe me. It is as I said already, important concept. We are given a matrix capital A. It is a 2 by 2 matrix. It is a 2 by 2 matrix. For this matrix, we have to find the inverse. This is a process. It is one type of process. You see, we know that A is equal to I into A. The multiplication of any matrix with I is the identity matrix, is as it is. No change at all. A is equal to I into A. That A is given matrix to 5 and 1, 3. Here I is 1, 0, 0, 1, A. Here we have to change by using the elementary operations, mainly row operations. By using that elementary operations, we change this left side A as I. You see there. A becomes as I and I becomes as some X. So X into A is I. Last, I will tell again. This LHS, that is that given matrix A, it becomes as I and that I becomes as some new matrix A, X. So X into A is I. By definition of inverse, A into any one matrix, if it is existed, whose product is I, that new matrix, that X is the inverse of the matrix. That is, A inverse is 3 minus 5 minus 1, 2. Here, you see, these steps are very important. You see, whenever if you want to change a given matrix as identity matrix I, first you try to see this is 1 and then it is 0. This is 1, it is 0 and it is 0 and it is 1. The first is we have to maintain to change as it 1. Okay, now you see here 2 is there and here 1 is there. By using the elementary operations, 2 minus 1. Okay, now 2 minus 1. Here also automatically 5 minus 3. So row 1 changes as row 1 minus row 2. That is what I meant. This is not standard. At every step, the first step is R1 changes as R1 minus R2. It's a wrong process. According to the problem, it can take places. Okay. So in order to get 1 here, 2 minus 1, 5 minus 3, that is applying the R1 implies as R1 minus R2. Automatically here also 1 minus 0, 0 minus 1. And the second row as it is. Okay, now, right. 2 minus 1 is 1, 5 minus 3 is 2, and 1, 3 is there. Here is 1, minus 1, 0, 1, okay. Again, in order to get here 0, here 1 is okay. Now we come to here, it is 0. That means 1 minus 1, that is R2 changes as R2 minus 1. 1 minus 1, 3 minus 2. Okay, now? So 1, 2 as it is row will not be changed, row 1. And row 2 is 1 minus 1, 3 minus 2, 1 minus 0, 1 minus of minus. So it is 1 to 2, 0, 1, 1 minus 1, minus 1, 1 plus 1 is 2. Okay, now? A as it is, that A will say. Again at last, Here 1, 0, 1, okay. Here we have to change as a 0. Here it is a 0. How can we change? You see 2 minus 2 only gives 0. 2 minus 2 into 1. Okay now? 2 minus 2 into 1. So R1 minus 2 into R1. Okay now? You see that? We are applying that one. 1 minus 2 into 0. So is 1. 1 minus 0. 1 minus 0 is 1 only. 2 minus 2 into 1. 2 minus 2 into 1. 2 minus 2. Get 0. And this row is unordered. 0. Here also, be careful. 1 minus of, I will write here. 1 minus 2 into minus 1. It is 3. So it is given. Here minus 1 minus this 2 into 2. Minus 1 minus 2 into 2. That is minus 1. Okay now? Like that. The remaining here R2 will not be changed. Okay now? Right. Now you observe. We get I. This is I na. I is equal to X. Okay now? I is equal to X into A. This is X, it is A, it is I. If you get this equation, then the X will become as a inverse of A. So, A inverse, we are finding for the inverse of A. A inverse is equal to this one. 3 minus 5 minus 1 and 2. This is the answer. Okay now? Similar, it is over. Ninth one. Given is A 3, 10, 2, 7. 3, 10, 2, 7. As usual, A is equal to IA, same. We have to change the left side, that matrix slowly by using that operations 1, 0, 0, 1, I. So, in order to get I, here it must be 1 and it is 0 first. So, 3 minus 2 we will get 1. 3 minus 2, 10 minus 7. That means row 1 minus row 2. Okay now? So 3 minus 2 is 1. 10 minus 7 is 3. And the second row is as it is, unaltered. It not be changed. Only we are applying the row 1. Here also the same application. 1 minus 0, 1. 0 minus 1, minus 1. And it is 0, 1 as it is in the A. Now, in order to get here 0, means, you see here, 2 minus 2 into 1. 2 minus 2 into 1. That is 0. So, applying the second row as row 2 minus 2 into R1. Okay now? So, it is as it is 1 to 3. 2 minus 2, 0. 7 minus, you see here. Here it is 7 minus 2 into 3. Okay na? 7 minus 2 into 3. That is 1. Similarly here also. 1 minus 1 as it is, no alter. 0 minus 2 into 1. 0 minus 2 is minus 2. Here 1 minus half minus 1. 1 plus 2, 3. Okay na? Any doubt? Try to understand. Again. Here 1, 0, 1 is over, correct. Now here we have to get 0. How can you get the 0? 3 minus 3. That means here 3 minus 3 into 1. 3 minus 3 into 1. You try to understand here. That is the twist in the problem. 3 minus 3 into 1. We are applying R1, changes as R1 minus 3 into R2. So, 1 minus 3 into 0, 1 minus 0, 1. 3 minus 3 into 1, 3 minus 3 is 0. And it is as it is. Here also the same thing done. 1 minus, be careful. I am writing here. You see, 1 minus 3 into minus 2. 3 into minus 2. It is how much? 1 plus 6 is 7. Okay now? Similarly, this one minus 1 minus 1 minus 3 of 3. That is 1 minus 1 minus 9. It is the minus. Okay, Nana? So it is a minus 2. 7 minus 2. Okay, na? And as it is minus 2, 3. Now we get I x a. Okay, Nana? X. That x is nothing but inverse of a. So a inverse. This is a inverse. A inverse is nothing but 7 minus 10 minus 2, 3. This is the ninth problem. Like this, you have to solve the remaining problems. Okay, now? Yeah. Yeah. One more problem, that is 12th one. The remaining problems you try to solve it in the same method. But it is a different one. Given matrix is A 6 minus 3 minus 2 1. Is there? Yeah. For this matrix we have to find the inverse. Already I told you. You take A, B, C, D. A, B, C, D, we assume. AD, the product of the first diagonal AD minus BC. Okay, now? AD 6 minus of 6 only. 6 minus 2 into minus 3 is plus 6. 6 minus 6. We get 6 minus 6 is 0. If you take AD minus BC, this is you assume it is A, B, C, D. If the product AD minus BC, if it is equal to 0, that type of matrix is not invertible matrix. That means it is not containing the inverse. We will prove. Here consider A is equal to I into A. 6 minus 3 minus 2 1 as it is 1 0 0 1 A. In order to get here 1, it is better to divide with or multiply with 1 by 6. Okay now? R1, in order to get here 1 instead of 6. R1 by 6. Here also you get 1. Okay now? Minus 2 by minus 2. That is why I am taking R1 by 6 and R2 by minus 2. That means we are multiplying each and every element of R1, first row, with 1 by 6. Here 1 by minus 2. So it will become as you see, 6 by 6 is 1, minus 3 by 6. Minus 3 by 6 is minus 1 by 2. Okay now? Right. And here it is second row. It is divided by minus 2. Minus 2 by minus 2 is 1. 1 by minus 2 is minus 1 by 2. The same application here also. 1 by 6, 0 by 6 is 0. 0 by minus 2 is 0. 1 by minus 2 is minus 1 by 2. That here is as it is. Again you see, here is 1 is okay. We need 1. But here 0. Here must be 0. Here also 0. If we multiply, here you see, in order to get 0, 1 minus 1, R2 minus R1. Okay now? R2 minus R1. We are applying that one. R2, first row is as it is, 1 minus 1 by 2. 1 minus 1, 0. Minus 1 by 2. Minus of minus 1 plus 1 by 2. We get 0. Here 1 by 6, 0 as it is. And 0 minus 1 by 6 minus 1 by 6. Minus 1 by 2 minus 0 is a minus 1 by 2. Okay now? Now, one twist is there. If any row or any column are zeros means here 0 into x, 0 into y. So second equation is not there. If all the elements of any row, here the second row, all the elements of second row, this is element, all elements of row 2 are zeros. Here zeros are there. So it is not possible. It is only one equation. X minus y by 2 is equal to 1 by 6. That is the meaning. Here 0 into x plus 0 into y is equal to something. It will not be formed. So this is not possible containing the inverse. So very simply you assume, if all the elements of a row are zeros, then it does not exist the A inverse. Simply you try to understand. Okay, Naina? So, for this matrix, there is no inverse at all. If the problem is given in the objective, then you simply apply AD minus BC. If it is not equal to 0, we can follow and we can find the inverse. Or if it is equal to 0, there is no inverse. That is, it is not invertible matrix. Okay, now that is the answer. Okay. Dear students, good morning. This is the last video for the chapter matrix. It is a part 16. Okay, now in this one, exercise 3.4, 14 problems solved, but in the 14 problems, some problems are given as homework. Okay, you try to solve it. Now it is a 15th problem. 15, 16, one more problem is there, 15, 16 and 17. These problems are very important. Out of these three problems, exercise 3.4, 15, 16, 17. I can solve 15 and 16. And you are given the 17th problem as homework. Okay, now you have to solve it. The remaining 14 problems are 2 by 2 matrix finding the inverse. Whereas this is a 3 by 3. Okay, now that is the given matrix A. 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2. It is a 3 by 3 matrix. For this one, we are finding the inverse by this method. It is one process. Through that one, we can find the inverse. Now, observe. This is a given matrix. Okay, now, as usual, we can consider A is equal to I into A. It is I into A. Any matrix can be multiplied with I means it will not be changed as it is A1, where I is the identity matrix. Capital A is the same matrix and I is this one, A. It is just like it is A1. Okay, now we are applying the elementary operations. Here you see, applying R1 and R3 both are interchanged. That is the first property. Okay, in the elementary operations, according to the rows, R1 and R3 both are interchanged. You see that this is R1 and it is R3. It can be interchanged. For R1 we get R3. 3 minus 2, 2. This R1 will be taken position R3. This is 2 minus 3, 3. 2 minus 3, 3. Okay, now R1 and R3 will be interchanged. The same operation here also we have to interchange. This 0, 0, 1 come to R1 place. 1, 0, 0, 0 here. Okay, now R1 and R3 interchange. Okay, that is the applying the elementary operations. Now, what is the necessary to apply like that? You see, here our aim is to change this A as I 1 0 0 0 1 0 0 0 1. Okay, now here we have to get 1 and here we have to get 0 0 like this. At the sudden it will not come. Slowly we have to change. Why? Because 2 minus 3 is a minus 1. If 3 is there, 2 is there, then 3 minus 2. Here you can understand. 3 minus 2. For that purpose, I interchanged R1 and R3. Okay. Now I am applying R1 minus R2. You see, R1 minus R2. 3 minus 2. We can get 1 there. Observe me, 3 minus 2. Minus 2. Why? Because R1 minus 2. R1 minus R2. 3 minus 2. Minus 2 minus 2. 3 minus 2 minus 3. As it is, the rows as it is, it will not be changed. Again here also, 0 minus 0, okay na, 0, 0 minus 1, minus 1, 1 minus 0, 1 na, okay na, R1 minus R2, R1 row, R2, R1 minus R2, 0 minus 0, 0, 0 minus 1 minus 1, 1 minus 0 is 1. The remaining are same, 0, 1, 0, 1, 0, 0, okay na, right. It can be simplified here. That is 3 minus 2, 1, minus 2, minus 2, minus 4, 2 minus 3 is minus 1. As it is, the elements. And it is again as it is. Okay now? Now I am applying R2 as R2 minus 2 R1. You have to see that. In order to get here is 0 and here is 0. First, in this method, if we are given the matrix 3 by 3, this is 1 and this is 0, 0. We have to melt it first. 1, okay, 0, 0. And then we will go to this one 0, 0. And it is 0, 0. This is one process. First we made here 0, 0. And next here 0, 0 at a time. Next it is 0, 0. Like this we have to change. For that purpose I am applying, see, R2 minus 2 R1. Here 2 is there, minus 2 into 2. Then only we get 0 here, 2 minus 2. R3 minus 2 into R1. R3 minus 2 into R1. Okay na? So here the first row cannot be changed. 1 minus 4, 1 minus 1. 2 minus 2 into 1. You see there, 2 into R1 is there. 2 minus 2 into 1. Here 2 minus 2 into minus 4 is there. 3 minus 2 into minus 1. Similarly R3, 2 minus 2 into 1. Here minus 3, minus 2 into minus 4, this one. Here 3 minus 2 into minus 1 is there. Okay, now here also the same thing. Okay, now, but I write directly. Okay, then you see 0 minus 0 is okay, here zeros. 1 minus 2 into minus 1, minus 2 into minus 1, plus 2. 1 plus 2 is 3. 0 minus 2 into 1, 0 minus 2 into 1, minus 2. Okay, na? Right. R3 minus 2 R1. Here also R3 minus 2 into R1. 1 minus 2 into 0, 0. 1 minus 0 is 1. 0 minus 2 into 1. Minus 2 into minus 1. 0 minus 2 into minus 1. That is plus 2. Similarly here also we get a minus 2. Okay, you solve it. Now simplification. 1 minus 4 minus 1. This is 2. This is 2 plus 8, 10. 3 plus 2, 5. Here also 2 minus 2, 0. Minus 3. It is plus 8. Minus 3 plus 8 is 5. 2 plus 2 is 5. Okay, now? Here you see here 10 5 is there. In order to make a simplification, I am applying R2 by 5. Means the elements of R2 second row divided by 5. Because 0 by 5 is 0. 10 by 5 is 2. 5 by 5 is 1. Simply we will get it. Why? Because in the properties, elemental properties, the elements of any row can be multiplied or divided with a constant. I am using a 5 to divide all the elements. The R3 also, R3 by 5. 0 by 5 is 0, 5 by 5 is 1, 5 by 5 is 1. Very simply it is reduced. How can we? It is a property is there. By using that second property of elementary operations, that is there. Here also we have to divide with 5. It is as it is. 0 minus 1, 1, 3 by 5, minus 2 by 5, yes, okay. 1 by 5, 2 by 5, minus 2 by 5. Okay now? Now applying R1 plus 2R2, 2R3 minus R2. How means? In order to make here is Here it is 2 zeros. Now we want to get 2 zeros here. Minus 4 is there. This is R1. Multiplying with 2. Minus 4 plus 2 into 2. Minus 4 means R1. Okay na? Plus 2 into 2. Okay na? 2 into 2. Okay na? Like that. R1 plus 2 R2. Here is no change. It is as it is 1 plus 2 into 0 is 1 1. Minus 4 plus 2 into 2 is minus 4 plus 4 we get 0. Minus 1 plus 2 into 1. Minus 1 plus 2 means 1 1. And its second is as it is 0 2 1. And again R2 R3 minus R2. 2 R3. 2 into 0 minus 0 0 1. 2 into 1 minus 2. In order to get 0, 2 into 1, 2 minus this 2. 2 into R3 minus R2. We will get here 0. Okay na? Right. And here also 2 into 1 minus 1 is 1. And here also same. By applying this one, by using the same method, we will get here. Okay na? Can you okay na? Right. Okay na? Like this we have to do the problem. Okay. Observe the continuation. You see, in order to make that given matrix A as I, that is our opinion. You see, here 1 0 0 is okay. But here you see 0 0 okay. Here it must be 1. And again here also 2 zeros. Will agree? So in order to get here 2 0 0, 1 minus this one, R1 minus R3, 1 minus 1, 0, R2 minus R3. To try to understand, here very important twist concept is there. In order to get 0, you may feel that R1 minus R2. Of course, 1 minus this one also. R1 minus R2 also gives 0 here. Okay, I will understand. But you see, here 0 minus 2 will come. 1 minus 0, 1, okay. 0 minus 2. Here minus 2 will take place. Okay, na? So, this can be unnecessarily it is changed. Here we have 0 and 0 in the second column. Here only zeros. The remaining as it is. If you take R1, this one, R3. R1 minus R1, 1 minus 1, we get 0. Here 0 minus 0 will not be changed. 1 minus 0 not. So here we should not do R1 minus R2, but R1 minus R3. Here also R2 minus R1, 1 minus 1, 2 minus 0, 0 minus 0. It will not be disturbed. So we have to applying R1 minus R3 and R2 minus R. Okay now? So that is 1 0. First one R1 minus 0, 1 minus 0, 0 minus 0, 0 and 1 minus 1 is 0. Similarly, 0 minus 0, 0. It is 2 minus 0, 0. It is also 0. Okay, now 2 minus 0 is 2. And 0, 0, 1 as it is. Here also, be careful. 0 minus 2 by 5. It is minus 2 by 5. Okay, now? Again, 1 by 5 minus 1 by 5. We will get 0 because we are applying the R1 minus R3. 0 minus 2 by 5 minus 2 by 1 by 5 minus 1 by 5 0. 1 by 5 minus half minus plus 2 by 5. Be careful. 1 by 5 minus half minus plus 3 by 5. So this is 3 by 5. Right. Next, R2 minus R3. 0 minus 2 by 5. It is also minus 2 by 5. 3 by 5 minus 1 by 5. That is 2 by 5. Minus 2 by 5 minus of minus plus 2 by 5. We get 0. Okay, now the third as it is 2 by 5. It is 1 by 5 and it is minus 2 by 5 into A is there. Okay, now any doubt? You clarify. R1 minus R2. R1 minus R2 minus 2 by 5. 1 by 5 minus 1 by 5. Okay, now 1 by 5 minus 1 by 5. That is 0. 1 by 5 minus plus 2 by 5. That is 3 by 5. Now everything is okay. 2 0 1 0 0 0. But here must be 1. So we apply R2 by 2. That is 1 0 0 0 1 0. Only R2 is divided by 2. And 0 0 1. Okay, now here only this is applying that application. Here also minus 2 by 5. 0 3 by 5. Here minus we are dividing with 2 now. R2 by 2 is there. Minus 1 by 5. Be careful. 2 by 5 by 2 is there. 2 ones. So it is minus 1 by 5. Okay, now again 2 by 5 by 2. 2 2 cancels. We get 1 by 5. Here 1 by 5. 0 by anything is 0. Here is as it is. Okay, now observe into A. Now we get in LHS I. This is I is equal to X into A. That implies inverse of A, that is equal to A. Inverse is nothing but that X. What is X? This is minus 2 by 5. 0 3 by 5. It is minus 1 by 5. 1 by 5. 0. It is 2 by 5. 1 by 5. And it is minus 2 by 5. Okay, now? Like that we have to solve it. Okay. Okay. 16th problem. 15 is solved. This is 16. 17 somewhat easy problem. That is why I gave you as homework to try to solve. And the 18th problem is it is an objective problem. Now 16. The given matrix is something 1 3 minus 2 minus 3 0 minus 5 2 5. It is a 0. Okay. As usual, consider A is equal to I into A. It is the procedure. A is, what is the given matrix? I have to take I 1 0 0 0 1 0 0 0 1 into A. Okay, now here is 1 is there, but our idea is to change these two elements as a 0 and then these two zeros and the last is a 0. Like this, by using this one we get like this. Okay, now first this is 0. How can you change these two or zeros to? With the help of this one minus 3 is seen as minus 3 plus 3 into 1. Will you agree? Minus 3 plus 3 into 1. Minus 3 is R2 plus 3 into R1. Will you agree? So that is taken here. Here also 2 with the help of this one. 2 minus 2 into 1. Will you agree? 2 minus 2 into 1. What is 2? This is R3. 2 into this is R. Okay now? Like that. So here it is as it is. Clearly I wrote all these steps now. You go through it well. Here also we apply that one. So we get 1, 3 minus 2 as it is. And here it is 0, 0. It is 0, 3 into 3, 9. 5 minus 6 is minus 1. Minus 5 minus 6 is minus 11. This is 4. And here is as it is. Again, in order to get this is 0 and is 0 with the help of 9. You see, here row 2, row 3 zeros means we are using row 1. By using row 1, we get zeros on row 2 and row 3. But here row 1 and row 3. Row 1, first row, third row. So we are using here. First row, third row. We are using the row 2. We can get this one. You see that? Here it is 3, it is 9. You have to use that 9. So that is the procedure. It is somewhat difficult one, but you have to learn it only. With this help 9, we have to change this as zeros. You see, it is 3 into 3 minus 9. Will you agree? In order to get here 3, 0, we multiply this 3 by 3 minus 9. Okay now? This 3 means 3 into this is R1 minus R2. That is what we wrote here. We are applying this application, elementary operation. Here also, it is minus 1 is there. It is 9 into minus 1 plus 9. Will you agree? Minus 9 into minus 1 plus 9. 9 into minus 1 means it is 9 R3 plus it is R2. Okay now? This method is a standard method. Like this, if you practice with our own effort, we can solve whatever is the problem. Okay now? Right. So by using here, directly I get the answer. 3 minus 3 into 3, 9 minus 9 is 0. Here 3 into minus 2, minus 6, minus half minus. Okay now? Minus half minus plus 11. Minus 6 plus 7 is 5. It is as it is second one. Third also same. We will get the, by using the that simplification. Arithmetic we will get this one. As it is here also we get the same. Now after getting this one, you see that here 25 is there. 25. 0, 0, 25. That row, if it is divided by 25, we will get 1 here. Okay na? Simply, very simply. So, I am dividing the elements of row 3 by 25. Why? Because 25 is there, 0 by 25 is 0, 0 by 25 is 0. Very simple. So, here it is by dividing, by applying this operation, you see 0, 3, 0, 5, 0, 9 minus 11, 0, 0, 25 by 25 is 1. But R3 by 25, here also we have to divide. Minus 25 by, 15 by 25. Minus 15 by 25 is minus 3 by 5. Okay na? Here 1 by 25. Yeah, 1 by 25. And here it is 9 by 20. Okay na? Right. And again, you see that, don't confuse, is somewhat difficult application is there, arithmetic is there, more arithmetic. R1 minus 5R3. Why we are getting R1 minus 5R3 means R1 minus, that means 5 minus 5 into 1. 5 minus 5 into 1. R1 minus 5 into R3. 5 minus 5 into 1. So this one. Okay na? In order to get here 0, here also 0. You see R2, that means minus 11 plus 11 into 1. Minus 11 plus 11. Plus 11 into 1 means R3 here. Here minus 11 R2 means. So we get here by simplification, you go through it. So by using that one, here also the same thing. Be careful now. It is R1 minus 5 R3. 0 minus 5 into 3 by 5. Okay now, be careful. 0 minus 5 into minus 3 by 5. Minus 1 minus 5 into 1 by 25. 0 minus 5 into 9 by 25. That R3 elements are written here. Similarly, R2 plus 11 R3. 3 plus 11 into minus 3 by 5. 1 plus 11 into 1 by 25. 0 plus 11 into 9 by 25. By simplification, see, it is 25. 3 into 5 is 15 minus 33. Minus 18 by 5. Here it is, be careful. It is 25 into 1, 25 plus 11, 36 by 25. Here also, it is 11 nines, 99 by 25, be careful. Here it is 25 into minus 1, minus 25, minus 5. Minus 30 by 25, minus 30 by 25, minus 6 by 5. Here also, 5 5's cancel, minus 9 by 5 is there. And it as stays. Okay now? Now, by simplification, R1 by 3, simply, 3, 0, 0 is there. R1 by 3, we get 1. And R2 by 9, 0, 9, 0 is there. 9 by 9, 1 will get. So, very simply, it will become as a identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. Here also, R1 by 3, 3 by 3 is 1. Minus 6 by 5, minus 6 by 5 by 3. 3 2 sir. So, it is minus 2 by 5. Here also, minus 9 by 5, minus 9 by 5 by 3, 3, so it is minus 3 by 5, okay now? Similarly, R2 by 9, minus 18 by 5 by 9, 9 minus 2, 36 by 25 by 9, 9 fours, 99, you see that, 99 by 25 by 9, okay now, that is 11 by 25. Okay, na? And as it is this one. Okay, na? It is as it is. Now we get I is equal to, this is x into a. That implies, what is A inverse? What is A inverse now? It is as it is. This is 1 minus 2 by 5, minus 3 by 5, and minus 2 by 5. It is 4 by 25 and it is 11 by 25 and it is minus 3 by 5. It is minus 3 and it is 1 by 25 and it is 9 by 25. Okay now? This is the A. You thoroughly 1 or 2 times, 3 times you go through each one. Otherwise it will not come. Our idea is the matrix, given matrix A is equal to A is there a consideration that A, that given matrix will be slowly changed as a identity matrix 1 0 0 0 1 0 0 0 1. First we have to change these two at a time 0 and these two at a time 0 and these two at a time 0 by the multiplication. I mean that row operation means elementary operations. Of course, the arithmetic is more, no doubt, but it is important problem. Try to solve it. Okay now? Yeah, the last 18th problem, that is the objective type question. The matrices A and B, they are inverse to each other. They are inverse each other. If they are inverse to each other means AB is equal to I and BA is also I. Okay now? Only this is the answer. We can understand it well. There AB is equal to BA. AB is equal to BA means that is equal to, that must be equal to I. That is the condition. The definition of inverse invertible matrix, that is the concept. So that one is wrong. Here also A is equal to null matrix. No, wrong. A B is equal to 0, B is equal to I. No, that is also wrong. So correct one is the D option. Okay, na? Like that. And one more thing. For this last problem, it is over. 3.4 exercise is over. But I want to tell something. First I taught the inverse trigonometric functions. But for some inconvenience, the students are unable to catch that one. But the days are going on. There is no solution for this. That means any medicine for this corona, COVID. So it may be, it is going on increasing. So that problem is there. So for that purpose I am telling, in the previous I told you, I suggested you, if it is possible you follow it, or otherwise we will come and we will explain on the board. But it is going on increasing this problem. So please try to understand. You go through it, that chapter inverse trigonometric functions. It is important one, and weightage also is more, as well as this chapter is also. For your convenience, I don't want to conduct any exam. Okay na? By conducting exam means you may write on in the front of your parents. Okay na? It is left to you. You can write, or otherwise you cannot write. You may by seeing the answer you can write it. So all of these things are there. I don't want to give that trouble to you also. So many difficulties are there with you. But if you go through these videos, the previous videos, you can easily you can understand. Or otherwise you ask me. My number is, you know it well. My number is there. It is 630201547. This is my new number. You know it well. By using that number, you call me at any time, and you give that question. You call me and you ask in the phone itself. I will give the answer. Or otherwise, you send that question through the WhatsApp also. And neatly I will give that answer on paper, and I will send it your number by WhatsApp also. Or otherwise, slowly I will give the answer step by step. Okay, then I try to understand it. What I want to tell you, the last words I want to tell. Slowly, by repeating the videos, you go through it well and study it well. Okay, now try to understand. This chapter is very important. I will take some gap, 2 or 3 weeks. I will not be there. Afterwards, after completion of the chapter taken by the Ramesh sir, after that one, after completion of the chapter by Ramesh sir, I will take again the determinants. That is the 4th chapter. It is based on this matrix. So you have to well verse about this chapter by giving everything I taught you. Of course, the 26, 27 and 28 examples are there. These are examples. It is miscellaneous examples. The miscellaneous chapter leave out, afterwards we will. Okay, now these examples are also important. And meanwhile, some examples are there before every chapter. Before examples are there, you try to finish it also. Slowly you go through it. That is my humble suggestion to give to you. Okay, now please try to understand. Okay, now nearly 2 or 3 weeks I will not be there. The next classes Ramesh sir will take. Okay, now bye, Lena, bye.